My name is RJ Sunderman. I'm a product engineer on the GeoEvent Server, Big Data, and Real-Time GIS team. With me here is Ken Gorton, another product engineer on our team. And we're going to be talking today about stream services and how you can leverage them as part of your output from GeoEvent Server. So thank you for making us one of your last presentations of the conference. Quick look at the agenda. We're going to take an overview of what stream services and stream layers mean in the context of GeoEvent Server, and talk a little bit about how GeoEvent services are published. Ken has a series of demos that he's going to be providing on publishing stream services, visualizing, and how to configure some sample applications. And then we'll wrap up with some references to tutorials and hopefully have a few minutes for questions and answers at the end. When we talk about real-time data, what do we mean? Some people are new to the concept of GeoEvent Server in real time, so let's take a look at what real-time data is. Some data just happens, like lightning strikes or crimes or tweets. And some data is moving around. We mentioned automated vehicle location here a few minutes ago, so airplanes, ships, trains, satellites, even radio collars that you might put on animals to track animal movements coming in and out of a preserve. But real-time data doesn't have to be things that move. You can have stationary sensors that are measuring air quality, temperature, pressure, humidity, maybe soil. You want to know how much water is in the soil for precision agriculture. That's an interesting use case of real-time data. All of this data can be brought into GeoEvent Server. So if we want to take an overview look at stream services and stream layers, let's put that in context of what GeoEvent Server is. GeoEvent Server is a server role that you add to your ArcGIS enterprise to bring the capability of real-time to your enterprise setup. And shown here on the screen, we have GeoEvent Server in the spatial temporal data store, and we have the ability to ingest data. That's primarily what we're interested in, is getting our real-time data into our enterprise GIS, and we have configurable connectors that allow you to do that. Once you bring the data in, a second key capability is the ability to run analytics on that data. Filter data events that are not of interest, discard them, or identify event records that are of particular interest. You want to be able to store the results of your analytics, and yeah, we can add and update feature records in a geodatabase. You can also stream the data out if you don't want to store it, and that's the focus of this session here, the fact that you have choices on how you disseminate or send the data out from GeoEvent Server. There's different ways of visualizing the data. Traditionally, if you're adding it to a geodatabase, you're going to be using feature layers to visualize the feature records that are in a feature class. But the feature records can also be broadcast via stream services. And finally, another key capability is actuation. Because GeoEvent is fundamentally RESTful, a lot of people integrate by HTTP post to send the data to GeoEvent. We can make HTTP post and GET requests on external services and devices as well to change their state or affect things that are in our environment by interacting with devices that are on the edge of the Internet of Things. Visualization using stream services is a little bit different than using feature services. Feature services, you can set a filter, for example, and every time you query or poll against the geodatabase, the filter is actively excluding those items that are returned to you from the display. So you always get everything, and then you throw a portion of it away. With stream services, you're only asking for what you want because you've specified a filter with the server, and thereby making better use of the network bandwidth in what is returned over to you. So sending features via a stream service is a push model rather than a pull model that you have with a feature class. As I mentioned, you can add and update features to an enterprise database, and that allows your clients, desktop, web apps, APIs, to pull the data and get the data out of the database, whereas stream services allow you to receive it directly via push. And if you're not using an enterprise database traditionally, a relational database, you can use the spatial temporal big data store, because one of the characteristics of real-time data tends to be either high velocity or high volume. And even if you're not receiving data at high velocity and volume, you tend to accumulate it over time. And once you accumulate several 100,000, million, or even hundreds of millions of records, you're outpacing what a traditional relational database can handle. And so you want to use the spatial temporal big data store so that you can do things like batch analytics with geoanalytics. The advantage to stream layers is that they're more responsive and they're more efficient. As I mentioned, you're setting a filter as almost like a contract with the server saying, I don't want to receive anything that is outside of this spatial extent. Or I don't want to receive anything if the attribute value is below a certain numerical value. Only send me data that I'm interested in. This also allows me to open up multiple clients, even side by side, and I might be broadcasting all the flights commercially for the entire world. But I can set up two filters, one for the Boston area and one for the San Diego area, and only be looking at flights that are coming in or departing from those two areas of interest by looking at two different clients. Both clients are subscribed to the same stream service, but they're specifying the data that they want to receive. Stream layers also display the data immediately. There's no need to refresh the web map with a periodic poll to get the most recent data. And the data is only sent once. So what is a downside to a stream service? Well, since you're not persisting the data, if you refresh the web map, the browser session that you have open, all that data disappears because you're not persisting it anywhere. But that may be exactly what you want. You don't want to write the data, you just want to put it up on a common operational picture as a web map. GeoEvent Server uses stream services that are published as part of the configuration of an outbound connector. Those of you that are more familiar with ArcGIS Desktop or Pro know that you want to bring in your feature classes as layers into a map document of some sort and then publish that as a service. Stream services are published from within the GeoEvent Server's Manager web application. You configure the output that you want to use to send stream services, and you publish the service as part of that workflow, and Ken will be demonstrating that for you. You will need a web browser that supports web sockets in order to leverage stream services and stream layers. But pretty much any modern browser, as you see here, Internet Explorer 10, Firefox 6, they all support the concept of web sockets. We do support both secure and non-secure or just WebSocket protocols, and there's no plugin required. So you don't have to download any additional software. The WebSocket is automatically able to, or the client I should say, is able to subscribe to the WebSocket to receive the data in the browser. Where can I use stream layers? Primarily inside web maps is where most people get their first experience. They load up the portal web map or their ArcGIS Online web map, and they add a stream service as a new stream layer. That is a JavaScript implementation and has for the last several years been the only way that you can consume stream layers. Jumping to my last bullet, ArcGIS Pro version 2.2, which was just released, has an implementation for stream layers now. And they actually have some additional capability inside Pro that you don't have inside the web map because it's not leveraging the JavaScript implementation, it's a native implementation for Pro. So those of you that have seen stream layers in the past and wondered why I can't do unique symbol rendering based on a category code, you can do that in Pro. And from Pro, you can publish out to the web map. ArcGIS Online and Portal for ArcGIS web application templates can incorporate stream layers, but only in 2 dimensions. And the web applications built using the Web AppBuilder can also leverage stream services and stream layers. You generally build up your web map and then incorporate that into the application. You can also use the JavaScript API if you want to build your own custom implementation of a stream layer because the web map is not giving you everything that you want. So Ken is going to take a look at demoing with publishing stream services now, and I'll hand control over to him.
Great. Thanks, RJ. Yeah, so before we get into actually publishing one, I'll show you, the steps that we'll go through to publishing. Basically, in GeoEvent Server Manager, we're going to create an output connector which will enable us to publish a service. And when we publish the service, you'll notice that while we're interacting with GeoEvent Server, you've got to remember that GeoEvent Server is really a component of ArcGIS Server, and what we'll actually be doing is reaching into ArcGIS Server and creating a new service over there. And then the final step that we'll perform to really complete the process is to take that output connector, that output that we generate in GeoEvent Server, and we add it to a service within GeoEvent Server so that data can actually flow from an input through a service and through our streaming output. Now, I mentioned that when we create that output in GeoEvent Server, it's going to reach into ArcGIS Server and create a new feature. If you're familiar with services in ArcGIS Server, you're probably familiar with the REST services directory. So when you create a service there, there's a REST endpoint that you can navigate to and that has a dedicated page where you can check out various details. And we'll leverage that numerous times throughout this, not only through this presentation, but as you get into using stream services and stream layers in your application, you'll definitely use the ArcGIS Services REST directory. So let me switch over here. I'm going to switch over to my browser real quick and see which one of these is my browser. There we go. And we're going to walk through a real quick demonstration of actually publishing a stream service. So what I want to do is that I already have a service set up in ArcGIS in GeoEvent Manager over here. If you're familiar with GeoEvent Server, this is the manager application. It looks something like ArcGIS Server Manager. This is where you'll build your services, you'll set up your inputs and outputs and sort of connect everything together. You notice that I have an input down here that is polling an external website for JSON, and this is the JSON represents the location, the current location of the International Space Station. And then I have a service here that incorporates that input. Right now, I just have it going to a text output, just so that I could have this service set up. Building the input, building the service is outside the scope of this discussion, so we won't really go into that into detail. But just for your background, this is the JSON that we'll be polling for once every second. So my input goes out to this external website and it fetches this JSON. If I refresh my browser, you'll notice that the timestamp here updates once every second. So that's what we're going to do. That's what this service actually does. And you can see that the numbers here are incrementing once every second, feature in and feature out. So what we want to do now is go to our outputs and create a streaming, to send this data to a stream service. And then we'll add the stream service into this service. So I'll go to my Outputs tab here, and I'll click Add Output. And I could scroll through all these, but I'll just keep it short here, and I'll search for stream services. This is the only output that we have here. I'll choose Send Features to a Stream Service as my output connector that I'll configure for this. And since this is the International Space Station, I'll call this ISS Stream Out. And so what I'm doing here is essentially choosing the ArcGIS server that I'm going to publish this stream service on. My default is the same service that I have here on my laptop. And I'll publish it to the root of that ArcGIS server. And since I don't already have a service that's suitable, I will click this button to publish a stream service. And this is where I'm reaching into ArcGIS Server now. It picks up the same name as the GeoEvent service that I'm about to create. And I'll specify the schema or the GeoEvent definition that is internal to GeoEvent Server that I'm going to send to ArcGIS Server so that it knows what schema, what structure to use to build that output, that streaming service in ArcGIS Server. Spatial reference is fine. It's going to be a point, but we could also use polylines, polygons, multi-points, etc. And the display field name, while not important, is sort of an optional field. I'll choose the name, and then I'll just take the rest of the defaults and hit Publish here. And that's really all there is. Now I've created a stream service in in ArcGIS Server, but I haven't really saved anything with GeoEvent Server yet. But that's easily rectified. I just hit the save button and that takes care of it. So if I scroll down here, I have this, I'll go to my page 2 here. There we go. ISS stream out. This just now started. And if I go over here to ArcGIS Server, my REST services directory, and refresh this page, I have ISS stream out. And since that service is already running, it's already once a second fetching the locations here, I can scroll down here and I could open this up in a JavaScript application or in a map viewer in ArcGIS Online. But a useful tool is the describe button down here, which I'll show here in a second. But first, I'd like to point out the fields here. This reflects the same schema as the GeoEvent definition that I specified. So I can just do a visual check. You know, the structure of this service looks like what I'm expecting it to look like. It has the same set of fields that we saw in that JSON in that external website of reflecting the location of the International Space Station. Now, if I hit subscribe, this is a good place for me to check that data is actually flowing. I'll hit the subscribe button and wait for a second. This is where it's establishing that subscription with the server. And I always do this. So I created this output. Why do you suppose data is not flowing? Because I didn't go back into GeoEvent services and actually add it to the service. I wish I had $1 million for every time I've done that. I'd be a rich man by now. So when ISS stream out, there we go, and this will fix that. There we go. So now we have data flowing, and about once a second we're getting an update there. So that's a good sanity check that that things are flowing, and this is exactly why. I just illustrated perfectly why you do this kind of thing. What did I forget? So that's it. That's what we've done here is just published a stream service in our GeoEvent server and ArcGIS server, and then this stream service now can be used in our downstream applications in JavaScript, in our web maps, in Web AppBuilder, in ArcGIS Pro to create a stream layer, and that layer then will leverage all the same data. So
there's a couple other things, Ken, that you also did by going to that HTML page. He proved that an external client can discover the stream service from the REST services directory and can make a client connection to the WebSocket, which is actually being run from within GeoEvent. So that's an important point, that if I were to stop the GeoEvent server, clients might still discover the stream service, but they wouldn't be able to find a WebSocket that they could connect to. Something else that he proved is that all of his security certificates are set up, and he's able to discover and connect securely to that stream service. If the security certificates weren't set up, the client wouldn't be able to do what he just did. So while it seems almost innocuous that he's going to the HTML page and clicking subscribe, he's proved a number of things in that demo.
Thanks, RJ. So let me switch back to my slides real quick, and we've got a quick succession of 1 or 2 slides and then a demo. So having created our stream service, we want to look at a few options for actually visualizing and leveraging that information. And the first of those, probably the easiest, is going to be utilizing it in a web map. We can open this up in ArcGIS Online or in our portal, and it's just a matter, if you've ever added a layer to a web map before, you go to the button to say add, and you have a number of things to choose from. We'll choose to add a layer from the web. And then you simply paste in the address of the URL, which I'll go back and copy in a second. You paste it in there, and it becomes a layer just like any other layer almost like any other layer in your web map, which you can then configure for symbology and filtering and so forth. So let's have a look at that real quick, at stream layers in web maps. So right now, from this page, this is the URL that we're going to want to paste into our web map. So I'll Control-C to copy that onto my system clipboard, and I'll switch to this next tab where I have just a blank web map. You're all familiar with this, so I won't go into that. But I'll simply go to the Add button. I'll choose to add layer from web, and I'll paste in the URL that I just copied to my system clipboard. So when I add that, I get a new layer in my table of contents, and the dot on the map indicates that I'm actually receiving information from that stream service. And every second you see the point is updating its location. I'll zoom out a little bit here so it doesn't scroll off our screen so quickly. But if I click on it, I can see all the same sets of all the same attribute fields that I was expecting based on the web page that we're polling. I can go over here and I can do things like configuring the symbology. Maybe I don't like the default blue button, the blue symbol that comes here. I'll choose a shape, the shape of my choice here. I can also choose to draw previous observation. Right now, it'll draw the previous 5 observations. I'm going to make that symbol a little bit bigger here. Let's see. There we go. 20 ought to do it. There we go. So right now it's we're watching the current observation in orange, and then it's trailing the previous 5 observations. I could do 5, 10, 50. I think the max here is 99. So you see it'll scroll up and it'll drag the 99 most recent observations. But then you saw that when I had just 5 of them, it was sort of like a moving breadcrumb trail following the most recent observation. I can, there are a lot of little things that I can do to affect the symbology here. If there were multiple tracks, such as aircraft or vehicle, ground vehicles or ships, and they had a heading value, I could choose to rotate the symbol, maybe using an arrow or an aircraft symbol or something like that, and it would show the direction that it's going. Well, the International Space Station doesn't report its heading, and besides, we're just using a round dot anyway. Now, one thing that people keep asking for is how can I symbolize my streaming layer based on some attribute? And the response is here that you can't do that right here, not through the user interface. We can do that programmatically. So we'll get into that in a little bit. You can also do this in ArcGIS Pro. But this is visualizing this data. Now, another thing that is very useful is, and here again, if you want to set a definition for your stream layer, you can do this just as you would set a filter on any other layer, a feature layer in ArcGIS Online. But some of the additional controls that are available here are specific to stream layers. So I could choose to stop streaming and the device goes away. If I hit start streaming again, I start to accumulate the points on the map as well. I can choose to limit the area to limit observations just to the area that I'm visualizing here. And this is, again, a way to just control what kind of information appears on the map. Again, if I'm streaming hundreds or thousands of features, maybe I'll only want to display what I'm in the area that I'm currently looking at. So I can choose that as well. And then if I just want to clear the previous observation. So I have a few controls here for streaming data that are unique to this type of layer. All right, so that's looking at stream layers in a web map. Now, the next logical step for a lot of people is to take that web map and build it into an application. There are a number of web mapping templates that you can use to create a 2D web app. And those will work just fine. It'll work in many ways the same way as using Web AppBuilder. But what Web AppBuilder brings is a stream widget that you can use to control some of the behavior of your stream layers within that environment. The number of ways that you can create a web app using Web AppBuilder. One is just to go to your My Content page and choose to create a new object. And you can create a new app and choose from a template or from Web AppBuilder. But you can also just start with that web app or the web map that we just created here, and share that as a web map, web application using Web AppBuilder. So to do that, I'll just go to Share here, and I'll choose to create a web app using Web AppBuilder. And immediately, just by default, it picks up most of the characteristics of the web map. So, you know, I could choose to change the web map, but that's the web map I'd like to work with. The key here that I'd like to demonstrate is going to the Widgets tab and adding the stream widgets here. It'll recognize that I have a stream layer in my web map and will allow me to leverage that because I didn't save the web map. Let me go back here real quick. There we are. So I save it. And now I'll be able to share this and go through this step again here from a Web AppBuilder, and there we are, much better. So there's the dot that represents the International Space Station. So I'll go ahead and add the stream widget into my web app. And it picked up the name of the layer here, ISS stream out, and it gives me a number of options. I can choose to be able to stop. I can enable the user to stop and restart the streaming and clear previous observations. I'll choose to enable them to limit observation to a specific area, especially if they want to draw an area on the map. Now, in this case, there aren't a lot of attributes that we can choose, but here again, if we were using a stream layer that had trucks or airplanes that had different attributes, we might enable an attribute filter. I'm not going to do that with the space station, but we might do that with future layers that we're using in future demonstrations. So we'll hit OK. Here's my streaming widget. Let me recenter here, and I'll save my web application, and I'll launch that. There we go. So here, if I zoom in a little bit so we can see what's going on, I'll go to my stream widget, and I can stop the streaming, and then everything goes away. I can restart it, and it'll start picking up features again. I can clear the previous observations. These are all things that we saw in the web map, so that's really nothing new. What we can do here is use a spatial filter to limit observations. So, for example, if I check this, if I want to limit observations by drawing on the map, I'll go ahead and use a shape here, and notice that it disappears until the streaming data, you know, is inside the area that I drew on the map. And then once the ISS passes outside that area, again, I'll lose my streaming data. All right, so we're not getting any updates. What you see here on the map is the last update that we received. Because I said I don't want any updates that occur outside this bounding box, the only thing that remains is what was already on my screen. So here again, I could purge all those, and you know, I'm not getting any more updates unless I clear that bounding box, and now I'm getting new updates here on my web app. All right, pretty straightforward. So now, with the most recent release of ArcGIS Pro, we added the capability to incorporate stream services into that application. So this is something that people have been waiting for a long time and been asking for. There are a few ways to get data into ArcGIS Pro, stream services into ArcGIS Pro, and you know, one of the initial ways that many people will leverage is if they have a stream service already published to their system, they can just go to their My Content in the portal catalog, find the stream service, and drag it onto your map or onto your scene in ArcGIS Pro. You can also add a server connection. All right, so if you have a local ArcGIS server or ArcGIS server here in your system, you can browse to that server, find all the services that are part of or that are hosted on that particular server, and again drag it onto your map or your web scene. Correction, not your web scene, but your scene within ArcGIS Pro. And then finally, you can just go to the Add Data button, and if you click that down arrow, it gives you a drop-down menu so that you can add data from a path. And just as we added data to our web map by copying the URL and pasting it in there. You can just paste it into the Add Data button, and thereby adding it into your map or your scene. Now, once it's in ArcGIS Pro, you have a few more options to interact with that stream layer. So, for example, whereas with the web map we couldn't really do a lot of classification on the layer itself to control the symbolization based on attributes, but with ArcGIS Pro we have that capability. You can set a renderer on that layer, and you can do things like, of course you can do single symbol, but you can also do unique values or graduated colors or graduated symbols based on various attributes. So here again, if you have trucks or airplanes based on the car, is it passenger, cargo, or freight? You can symbolize the streaming features differently based on a given attribute. Whereas just in the web map, we could visualize current features as well as historical features, previous observations. You can symbolize them differently, and that becomes very useful, so that you can highlight where something is now, but you can also see where it's been most recently. You also have the opportunity to vary the symbolization based on certain attributes, and as I mentioned before, a common one of those is to be able to change the orientation of a symbol based on the heading, but you could also change the transparency, for example, based on some other value that indicates a magnitude of something, or various other attributes that might be present in the data. So let's walk through that a little bit. I'm going to switch over now. Instead of using a web browser, I'm going to go to ArcGIS Pro. And so right now what I have here is I have a map, just a blank map, and I have a scene here. So we're going to do some 3D in this one. And in my catalog, you notice that I already have, I've navigated to my server's node, and I can connected to my local server. This is the same server that I'm working with here on my laptop. So this is where you see the ISS, let me refresh this here so we see. There we go, ISS stream out. This is the service that I just recently published to my system. So I can go ahead and add this to my map, or if I go to my map, I can open up the catalog over here and do the same thing and just drag it on. So here I'm getting updates of the International Space Station in my map in ArcGIS Pro. So similarly, I have a few other services over here. If I open up my browser, there's I connected to a remote server. There's some sample services that we have on a server, here within the real-time and big data team. The Flight Aware Positions is a streaming service that shows the current location of aircraft around the world. So I can go over here again, and I can do something like I go to my Add Data button and paste in the URL. I'll turn off my ISS layer so we don't get those confused. But here we go. We're streaming in data for aircraft updates, positions around the world. And each one of those, if we click on it, we can see the details about a particular aircraft. We can see the identifying number, the airline, various other things like the altitude, 36,000 feet. And so based on this, we'd be able to use, say, like the airline attribute to symbolize that information. And symbolizing it, I won't go into that in detail. It's like you'd symbolize anything else in ArcGIS Pro. You right-click the layer and choose to symbolize. Here I'll choose unique values, and I'll pick the airline field. And wait for it'll interrogate all these. There we go. So there's quite a lot of airlines, but you can see, you get the idea that it's it's a powerful way to be able to visualize the data. Here's another example. If I go to for example, a scene, I could paste in that same data, and this is actually kind of cool to be able to visualize this data in 3 dimensions. So here we can see the aircraft all over the world. I'll try and zoom in to just the edge of the world here. Whoop. So we can see that information in, where are we going here? There we go. So you can see the data. These points are above the horizon here, so we're already visualizing this information in 3 dimensions. Here's another good example of some good 3D data that we can visualize, and these are the world satellites. And this is really one of the things that's kind of cool. What I'd like to demonstrate here is using using this information, or using a definition query. So right now it's streaming in all the world satellites, and it'll take a little while. You see them coming in here. Let me go ahead and symbolize these in something a little bit more visible for us. And I'll change this to go to my properties here, and I'll change the type from, instead of a shape marker, I'll make it a 3D marker. Give it a nice bright vivid color that we can see, and I'll just make it some kind of a sphere here. There we go. Drop the size of that down a little bit. There we go. All right, so we can see those a little bit better now. And right now it's streaming in all these satellites. Well, there are a lot of satellites in this catalog. These are everything that NORAD is tracking, right? So what if we don't want all these satellites? What if we only want the ones in low Earth orbit that are close to, relatively close to the surface of the Earth? Just as with any other layer, we can set up a definition query. And I'll add a clause here so that indicates the altitude in meters is less than or equal to, low Earth orbit is defined as less than 2 million meters, or 2,000 kilometers above the surface of the Earth. 1, 2, 3, 4, 5, 6, there we go. That looks like 1 million. All right. So it'll clear all the points that I have here in the map, and now it'll just start to stream in everything that's only in that low Earth orbit. So we're not getting all the satellites that are out there in high Earth orbit or geosynchronous orbit or any of the really, really far out orbits. But still, it's bringing in all the same information. We can interrogate this information. You can see what the satellite name is, and if we sit there and let this stream in for a little while, it's showing us both the current observation as well as the previous observation. So we'll begin to accumulate a breadcrumb trail for these satellites as they stream in. Another thing that is useful, and this is something that goes beyond the capabilities of your using your web maps, and that is that you can leverage stream services in your geoprocessing tools. And this is something that people want to be able to do. You do have some consideration that you want to keep in mind. Remember that when you're streaming data in, you're not necessarily always getting a full snapshot of all the data that's out there. You're getting a snapshot of what you have since you started receiving that information. So when you go to leverage a stream service in one of these tools, it's one of the best practices that we recommend is that you go up here to your data tab, and the data tab is where you'll have the controls that allow you to work with your stream data. And so if I click on the layer, give it a chance to catch up with me here. There we go. One of our best practices, one of our recommendations is that you stop streaming so that you can see you can work with a sort of a fixed set of information. So this is the only way I can view these attributes is by stopping streaming, and then I can open the attribute table and I can see what's there. So right now I've streamed in 491 points, and if I want to work with a geoprocessing tool, it would act upon those 491 points. It's not, and like I said, it's a best practice. It's not a requirement, but you get unpredictable results if you start to operate on sort of an unfixed number of features. All right. So when I click on the stream layer here in ArcGIS Pro, you notice I do have, and I go to the Data tab, I have a few extra controls that are available to me by virtue of the fact that I'm working with a stream layer. Now remember, one of the first things I did was set that definition query, and here we have a list of all the definition queries that are part of that layer. And I could choose to use that one that I set, or I could set it to none and start to stream in all the satellites once again. I'll go ahead and leave it there so we don't inundate the screen with everything. Now, one of the things that people want to be able to do, and I'm going to point out one of the differences between using a map versus using a scene, and that is to be able to share this information. If I want to be able to publish this information out to to the web, to my portal, to ArcGIS Online, now I can do that, but I want to be aware that, as RJ mentioned, the JavaScript APIs and ArcGIS Online and the portal are built on our JavaScript APIs, only support 3D data in the JavaScript 4 API. All of our stuff is built on the JavaScript 3, so we're limited to supporting 2D applications. What does that mean? Well, in ArcGIS Pro, I can go to my map scene and I can publish this layer as a web map, and it'll pick up all the same symbology. I can so this is flight aware, right? So I'll call this my flight aware with one L. And I'll analyze this. I'll go ahead and fix that error issue. And now I can share that. And it doesn't take but a moment. I mean, it's not really pushing any data out to ArcGIS Online. All it's really doing is sending that configuration. But it's creating that web map online. And as soon as it's done, I'll be able to go to that web map and see it on the web. Now I have this stream layer that I've just created a web map for. This is based on the symbology that I set up in ArcGIS Pro. That is not the organization that I want. There we go. There we go. It'll help if I sign in with the right user, right? There we go. So if I open this in a map viewer, you know what we have here. This is just a web map that I published from ArcGIS Pro. So I can open this in my map viewer. So it's because that flight aware layer is a protected layer. It wants me to sign in and prove that I have access to it. So it still has my ISS stream there. But you see that it's bringing in that same stream layer now, and the symbology is intact from the way I set it up in ArcGIS Pro. So this is a way that you can take a stream layer and symbolize the values of that stream layer based on a certain attribute. And each one of these points is symbolized based on the airline to which it belongs. Now going back to ArcGIS Pro, what I'd like to do is take that scene that I just added the satellites to, and I'd like to share that as well. Unfortunately, as I mentioned, I won't be able to do that. I can't share this as or I could share this as a web scene but because web scenes, streaming layers are not a valid layer in a web scene, it'll strip everything out, and I'll just have the globe, and that's useless to me. So I won't go through that exercise just to show that the limitation here. Just so I want you to be aware that this is something that don't get frustrated if you want to be able to do this. However, all is not lost, because once again, the JavaScript 4 API does support 3D data, and so you can use a streaming layer in a JavaScript application that you build if you write it yourself. And so this brings me to the last couple of slides that I have here, and that is leveraging 3D data, streaming data in your custom applications. So to do this, you turn to the JavaScript API. And as we mentioned before, that we have two varieties of the JavaScript API. Version 3.x, which handles 2D data, and the version 4.x, which handles both 2D and 3D data, depending on what you require it to do. And rest assured, I'm not going to go through a coding exercise, so I don't know, how many developers are there here? Not many hands going up. All right, so the rest of you will be happy that I don't go through and start writing code here. I am going to flip over to my browser, though, and the other browser, there we go, and flip to this. Here's an example of a custom JavaScript 4 application that is built to consume a stream service. So it has a 3D stream layer in here, and this is the International Space Station once again. So you can tip the world on the side here and then zoom in a little bit so we can see this. So not only are we showing the International Space Station, the current location, as well as previous observations, but you'll notice that the current observation is symbolized with a relatively realistic looking model. So this is a 3D model that we downloaded from the NASA website that they make available. So we can actually see what the space station looked like, what its current orientation and its position above the Earth. And all this information is part of the ephemeris data that's part of that satellite data stream, so that we can orient the symbol realistically. Just a simple example of a custom JavaScript application that does that, so that you can leverage 3D stream services in your application, your client applications. So there are a number of resources that you can leverage to explore stream services in more depth. First of all, I direct you to, for the developers among you, or those of you with developers in your organization, we do have quite a bit of API help for writing JavaScript apps, and these include samples as well as API references and documentation and best practices for both the 3.x as well as the 4.x API. We have a number of sample applications on GitHub that you can download and utilize as well. There are a couple of servers here that have sample stream services, such as the world satellites data that I showed you, and there are some others as well that show shipping and aircraft that you can leverage, so you can sort of play around in ArcGIS Pro or in your web maps and web apps and so forth. We have a number of tutorials as well as discussion blogs on GeoNet, so I'd encourage you to log in there and sort of continue the discussion. They're a good resource to be able to ask your questions and see what other people are doing and what their experience has been. Now, it's not useless to show this screen, even though all of these sessions are already in history, because in a few weeks we'll publish the videos for all of these sessions. So this is good for you to know what other sessions that you might have missed that you can go and look for online and see and look for the videos of those sessions and sort of review what was presented there. So I would definitely encourage you to do that. I would also ask you to fill out the evaluation for this session, so that RJ and I and others on our team can know what worked for you, what was useful information, and what was if you have suggestions for improvement. That information is very valuable to us, and it does get to us, so we would appreciate that. The real-time and big data team also has put together this survey that we would ask you to go to on this Esri URL. This is a good place for you to share what you have, if you have challenges with GeoEvent or with our real-time technology in general, or questions, desired directions that you'd like the technology to go, use cases that you're trying to implement or would like to implement that you'd like us to consider. This is your opportunity to provide us with feedback about what direction you'd like the technology to take in the future. So here again, we very much ask you to do this. We would appreciate any assistance you could provide in this because it's valuable to us.
I also have business cards up here with this URL, so you can take one of these with you if you want to fill out the survey later, or you can just take a picture of the slide.
So with that, we have a few minutes yet for any questions that you might have. Yes, sir.
I'm military. I have a juridic problem when a tweet says that you don't guarantee when I have a geofence and I have 1,000 of airplanes that come in this geofence. You not guarantee the 100% that they log this passage. Sorry for my poor English.
No, it's quite all right. So are you asking if you have a geofence and you have a stream of data, can we guarantee that every single data point that is coincident with that geofence is reported?
We need to log in this.
Okay.
But someone says that you can guarantee that 100% are logging. You can confirm this as a problem.
That we.
There's a workaround to resolve.
So the question is, can we not guarantee that 100% of those features will be logged? Are you familiar with this, RJ?
So that's a little bit outside the scope of this session for leveraging stream services and stream layers. I would invite you to come to talk with me after the session.
Yeah. So if you have an issue, we can discuss that. Yeah. Sure. Yes, sir.
Is Event Server available in ArcGIS Online?
No. The question is GeoEvent Server available in ArcGIS Online? GeoEvent Server is a component of ArcGIS Server, and as such, it's an on-premises feature. So you could have virtual servers in the cloud, but it still requires ArcGIS Server.
So it's a license role that you add to your ArcGIS Enterprise for your on-premise deployment. We are coming up with a software as a service option. I can't give you a release date for that, but there is real-time coming to ArcGIS Online soon.
Right. Yes, ma'am.
Does the stream service work with ArcGIS Server at all? Can you bring it in at LowEarth?
No, that's a great question. The question is, does a stream service or stream layer work in ArcGIS Earth? I have to admit, I haven't tried to do that. Yeah, I guess I have to go and try.
So you could publish it, or you cannot publish it to a 3D web app?
A 3D web app. Well, a 3D web app can feature a 3D streaming service, but you have to write it yourself. Our web app templates and Web AppBuilder will only leverage web maps with stream services. They won't leverage web scenes. That's because stream layers are not a valid layer in web scenes.
So I could take the layer as a web map and publish it to a 3D web app?
You could take the layer in a web map and publish a 2D web app. Yes. Yes, sir.
That would be one.
Yes.
The initial JavaScript that comes in, does that have to match one-to-one on the stream that comes out, or can you filter that out? So, i.e., there's fields that I don't want to stream out of it?
So if I understood your question, within GeoEvent Server, once the data comes in, can I apply filters to reduce the amount of data that goes out on my stream service? Is that right?
Correct.
Right. Certainly, the GeoEvent Server allows you to modify and throttle the flow of data within it using filters and other processors. So you could modify the schema, or you can buffer the point and create new geometry for it. So you have all that kind of control. Yes.
And that gives me an opportunity to comment on the tutorial. So while we gave you an introduction here to stream services and stream layers, there is a tutorial specifically for leveraging stream services that comes with 3 short videos. They're about 7 to 10 minutes. The first one shows the International Space Station that Ken was demoing here, but it also includes in the workflow limiting the number of feature attributes that I want to push out, as well as using a field calculator to adjust the date time from what was reported in seconds to what's reported in milliseconds, which is actually what GeoEvent Server expects. Those videos also go into additional capabilities that we didn't have time to cover in this session, related features and store latest. Related features, just briefly, is when you have geometry stored in a feature service, say for your fixed sensors that aren't moving, because the stream service itself is not broadcasting position. But you want to show the real-time data, the temperature, pressure, humidity on a web map, so you can join to the related features in order to get the geometry for displaying on a web map. And then, of course, store latest is where, as Ken mentioned, when you subscribe, you're only getting the data from the point that you subscribed. If you want to know the last recorded observation for these feature records, you can use store latest so that you're storing this information, and now the client will bootstrap the display by doing a one-time load from that store latest feature class to get the most recent observation, so you're not waiting for the next observation. You can see where it was prior to you subscribing. So take a look at the tutorial, because there's additional capabilities for stream layers.
Build operations dashboard pages for computers, things like that around stream layers?
You can build an operations dashboard. The web map widget will support stream layers. What is not currently supported in operations dashboard, but coming soon, is the ability to hook up your gauges, your charts. Those are only looking at the snapshot that is when the stream layer was first added to the operations dashboard. Kind of like Ken said, you need to stop streaming if you want to do an analytic. So they're building in the ability to make those charts dynamic and responsive to the streaming data. Right now, just the web map widget will work with the streaming data.
In the GeoEvent Server, in the services tab, you show the input and the output diagrammatically. And I'm just wondering if you're heading towards incorporating geoprocessing tools as a workflow in that environment.
The question is, are we planning on incorporating geoprocessing tools into the GeoEvent Server, GeoEvent service design? The answer is probably no. There are design principles within GeoEvent. We're trying to push through 5,000, 6,000, 7,000 events per second, and a lot of the geoprocessing tools are more thick client application that you want to either do batch analysis, or they're taking longer to run than, say, a filter for altitude greater than 200 or point inside polygon. So while GeoEvent services look kind of like Model Builder, they're using a lighter weight real-time analytic than what you would experience with your 700, 1200 geoprocessing tools that are available through Pro and Desktop.
Yes.
Do I understand correctly that the tables are not dynamic? Tables?
In the operations dashboard, tables are not dynamic, only the web map. But that is the operations dashboard consuming the stream service as a stream layer.
Say for pop-up, say in ArcGIS, you pop-up and you want to see that update over time, but that's not going to update, is that going to just sit kind of static over?
No, I think the pop-up is dynamic in Pro.
Right. Yes, sir.
It seems like that sample server that you put up requires that you make a password. Did I get that wrong?
I'm sorry, what was the question?
Resources up there, the sample server, I think it's slides back.
Here?
Yeah, GeoEvent Sample 3.
Some of these services on GeoEvent Sample 3 are secured because we have agreements with, say, FlightAware that we're not going to expose the data that we are consuming as a partner with the general public,
Right.
but other stream services are available. So maybe what Ken was using did require authentication, but there are some stream services that are available open on that sample server.
And I would also point out here that GeoEvent Sample 1 is also a server that has a number of right now I'm not logged in as anything, so these are the layers that are available on GeoEvent Sample 1. So here, let me, there we go. How's that for service with a smile? Other questions? Yes, sir.
Are you aware of any streaming services that work with telephone information, so where phone calls come from, and documentation of how you would create a service that would handle something like that?
So you're asking on how you would create an input to receive what, phone calls or?
To take phone call data.
Okay.
And then so you can dynamically see where calls are coming from.
Sure. So just conceptually, in order to be able to do that, you need to enable GeoEvent Server to be able to access some source of that information. So connecting to a cell phone carrier, for example, provided they would be able to provide that information. So if you have those sorts of resources, then if that information could be provided in a table of a feature service or through some API, through a REST endpoint, then GeoEvent Server could be set up to periodically pull that information and bring that in. It's essentially the same thing we did with the International Space Station. I just set that up to pull an external website. So if a phone carrier would provide most likely a secure website that you could log into with proper credentials, then you could pull it periodically and bring that data in. That's one possible way I can imagine that could be done. But I don't have personal experience in implementing a solution that specifically deals with phone call data. So I don't know. Have you ever seen something like that?
No, it looks like we're a little over time.
Oh.
We should probably wrap up the session and the recording. Ken and I will be here for several minutes after, so please,
Sure.
if you have additional questions, go ahead and come on up.
Right. Thank you very much.